Hi, and welcome to the SDS training on understanding SDS and chemical hazards. In this training, we will look at what are SDS, what types of information we can find on SDS, how to read and understand chemical hazards, disposal considerations. We will also familiarize ourselves with some of the OSHA requirements about SDS, and at the end, we will recap what we learned today to ensure that we understand our roles when handling chemicals. So what is an SDS? The Occupational Safety and Health Administration, also known as OSHA, is a division under the Department of Labor that was put into place to ensure safe working environments. Included under these responsibilities, OSHA is responsible for ensuring entities adhere to guidelines when transporting, handling, and disposing of hazardous chemicals. OSHA also requires all chemical manufacturers and distributors to provide SDS to its customers. Safety data sheets, also known as SDS, replaced historical material safety data sheets, MSDS, as a homogeneous method of delivering information on hazardous and non-hazardous chemicals. The information and layout of the MSDS were largely up to the manufacturers. While they were required to have 9 sections, the order and the information within these sections widely varied. The newer SDS have a more rigid structure that allows for end users to quickly and easily find needed information. All SDS have a format of 16 sections, each section containing specific predetermined data. Next, we're going to take a look into each section of the SDS and the information contained within each. Going on to look at section 3, we see this gives us our chemical or product information. Here you can determine the purity and what other constituents may be included if the substance is a mixture. Section 4 is important because it gives us further first aid guidance for if you or someone around you comes into contact with this product. For our lead chloride, we can see that they give directions to rinse the affected area if in contact with your skin or eyes, move to fresh air if inhaled, and not to induce vomiting. All of these measures also indicate Going on to look at section 3, we see this gives us our chemical or product information. Here you can determine the purity and what other constituents may be included if the substance is a mixture. Section 4 is important because it gives us further first aid guidance for if you or someone else comes in contact with this product. For our lead chloride, we can see that they give directions to rinse the affected areas if in contact with skin or eyes, move to fresh air if inhaled, and to not induce vomiting if ingested. All of these measures also indicate to seek medical attention. If you or someone around you comes into contact with a chemical, these first aid measures must be followed. Now let's take a look at sections 5 and 6 of the SDS for sodium chloride. Section 5 explains measures to take in the event of a fire, while Section 6 advises what to do in case of a spill. Let's look at the SDS for sodium chloride as an example. We can see that it tells us that the substance is not combustible, and in case of a fire, to use a tri-class fire extinguisher. Notice that it tells us specific type of fire extinguisher to use in order to properly extinguish the fire. It is important to use the correct type of fire extinguisher in these types of cases. Section 6 talks about accidental releases. In the lab area, this is most often in the form of a spill. We see that it tells us to sweep up the substance and put it in a bag for disposal. Sections 8 and 13 will give us more information about cleanup procedures. If the substance creates additional hazards, such as the release of toxic gas, this section may direct you to leave the area and move to an area of fresh air. Be sure to follow any directions from Section 6 when dealing with chemical spills. Looking at the next two sections, Section 7 gives us information on safe handling and storage procedures, and Section 8 tells us how to minimize exposure. For these two sections, let's look back at the lead chloride SDS. Section 7 tells us that we should only use lead chloride while under a hood and indicates that the dust and fumes are toxic. It also gives us directions to store the chemical in a cool and dry place. Handling instructions are especially important to us as chemistry faculty and staff. It is our responsibility to ensure students are working in a safe environment and in a safe manner. It is also important that we ourselves handle these chemicals in a safe manner. Neglecting to follow safe handling procedures can result in chemical exposure of students, yourself, and other faculty or staff around you. Section 8 tells us about exposure control and required personal protective equipment. For lead chloride, we can see exposure limits from a number of agencies. We can see that NIOSH, which is the National Institute for Occupational Safety and Health, sets exposure limits for us. We can see that they indicate the IDLH, which is the immediately dangerous to life and health exposure limit of 100 micrograms per cubic meter. It also tells us to ensure that there is an eye wash station in the area as well as proper ventilation. This section also tells us what PPE guidelines should be followed when handling this chemical. We can see that they advise users to wear gloves, eyewear, and appropriate clothing such as a smock or lab coat. Continuing on, we see that Section 9 gives us the physical and chemical properties of the chemical. This may include information such as the molecular weight, flash point, and physical characteristics of the product that can assist us in identification if the substance is unknown. Section 10 details reactivity information. We can see from this SDS that lead chloride reacts violently with bromine trifluoride and lithium, and that mixing these substances should be avoided. It's important to always check this section if you're mixing two or more chemicals together to ensure safety. It also tells us that it's somewhat hygroscopic and may need secondary containment or to be replaced periodically. If you or your student had been exposed, Section 11 will give us further toxicological information, including the IDLH we saw in Section 8 and some effects exposure may cause. Sections 12 and 13 of an SDS help us to determine how to properly dispose of a chemical. Section 12 indicates what ecological considerations should be considered. On this SDS, it tells us that the data is not yet available. SDS for other chemicals may specify not to allow the chemical to reach the sewers or that it's acutely toxic to aquatic environments. Take special considerations of this section before disposing of any chemical wastes. Section 13 describes further disposal considerations. This SDS of sodium chloride specifies to check our local, state, and federal regulations before disposal. If you want to dispose of a chemical but are not sure of these regulations, please check with your local chemical hygiene officer or someone who holds a current RCRA hazardous waste management certification. Sections 14 through 16 are not always applicable for us as end users. Section 14 describes how a chemical must be transported. Section 15 gives us regulatory data. And Section 16 details any other information the company wants to convey about their product that otherwise does not fit in the previous sections. So far, we have looked at each section contained within the SDS. We were able to identify hazards in Section 2 of an SDS that should be taken into account before any experiments are performed. We also saw that Section 13 gives us disposal considerations. If you read through an SDS and are unsure of safety or disposal measures that should be taken, stop and ask your technician before proceeding. Now that you know the sections of an SDS, where do you find them? This answer may not be so straightforward because each lab will differ. In the chemistry labs on the Utica campus, you can find our SDS in paper form in the instrument room. These folders contain an SDS for all chemicals housed within the chemistry labs and are organized in alphabetical order for ease of use. You can see them in these green folders with the orange and black tape down the center. You can also find those digital copies of all of our SDS on the lab computer's desktop. You can see that these SDS are also organized alphabetically. So what if you cannot find an SDS for a specific chemical that you'll be using? What do? From any MVCC phone, you can call me, the Chemical Hygiene Officer, at extension 5525, or Mr. George Aylesworth at extension 5645 for further assistance. There are additional numbers you should also be aware of in case of a fire or major spill. I have detailed these here, and you can see them in the yellow to orange color on the right-hand side. These numbers can be found posted above the phone in the chemical prep room, but you may also want to take a moment to write them down in the event that you're not able to access that area of the lab space. So, time to recap. In this training, we learned about safety data sheets, the information contained within, as well as how to find an SDS for a chemical you or your students will be working with. Remember to pay special attention to sections in an SDS pertaining to safety and exposure controls, as well as disposal considerations. Our goal is to keep faculty, staff, and students as safe as possible while performing experiments and to protect our environment through responsible disposal methods. Make sure that you know where SDS can be found in the lab area you are working in, as well as important numbers to call in the event of a major spill, fire, or to obtain information on an SDS. Thank you for attending this training. Please feel free to forward any questions or comments to me at my email on the previous page. I hope this training will help everyone to have a safe and meaningful laboratory experience.